Hi everyone, in this tutorial we will be designing some nuclear DNA primers for the family colibrids. Within these family we will be designing some primers for the REG1 gene. To start off with, what we need to do is first go on TimeTree. This is a website. You can go on Google and search it. It is not the TimeTree AMP or TimeTree app. It is the timetree.org. Once you go on it, this is basically trying to build a time tree for any of the families or genera you're interested in. For this one, we are interested in the family Colibrids, which should be written like this. And as you can see on the right side, it gives me several options: family, genus, or species. I'm interested in the genus level, so I'm going to click on genus and click on show time tree. This website uses a bunch of studies, so it might not be the most reliable, but rather it's trying to create a metadata from all of those studies together. This is why we're seeing Lycodon 1 and Lycodon 2, and completely separate from them, there should be Lycodon 3, Lycodon 4, and so on, and even Lycodon 7 right here. So it is not the most reliable, but for the nuclear DNA, since most of the genes are quite preserved, it should be sufficient enough to do to our job. What I'd like to do is design a primer, let's say, that'll fit both for the oligodon right here and then the lycodons right here. Now, just because we would like to design some primers for these two species doesn't necessarily mean that we have the whole genes for those species. So what we are going to do is go on Google and click on search NCBI datasets. Once we do that, click on the first link, click on taxonomy, and let's find the chordates because that's what we are interested in. Now within the chordates, this is basically a database that shows for what species and what genera whole genome sequences are available. So right here we're looking at the chordates, and within chordates we are interested in Lepidosauria, which is lizards and snakes, and after that we're going to go into the squamates, and after that we are going to be going to colubrids. These are the colubrid snakes. Now after that, although we would like to take a look at the oligodon and lycodon, as you can see, we do not have the whole genome sequences. Now let's see if we actually have the reg1 sequences for those. But again, we are looking for the complete ones. So let's search it on NCBI with the nucleotides, and as you can see, nothing came out. Same thing for lycodon, reg1 complete. As you can see, nothing came out. Now there are some reg1 sequences available for lycodon, but these are all partial sequences, which is not going to be enough to design primers as freely as possible. So let's go back to the NCBI's website, the first one, and see that from these genera we see here, there's a good chance that these are going to have the whole reg1 gene available. Now, just because one of the, let's say, Greya smithi, yeah, let's select this, Greya smithi. Just because we have the whole genome sequence for this species doesn't necessarily mean that the reg1 sequence will be available, because it might not be annotated yet. So let's go on NCBI again, nucleotide, and let's search for Greya smithi reg1. And as you can see, nothing came out. That's because although we have the whole genome sequence available for Greya smithi, the reg1 gene hasn't been annotated properly. And because of that, either we have to blast and then see if the blasted search actually gives us the reg1 sequence, or we basically cannot use the Geneious smithy for this. Now, one thing is Thamnophis, which is quite a bit of diverse and available species in the North United States. That means there's a good chance that the reg1 will be available for Thamnophis. So let's go back to the coordinate data we have. And from the colubrids, as you can see, these are all of our options. Now, back on the time tree, Thamnophis might not be the closest species available here, but again, for the nuclear genes, they're going to be quite conserved. So even if they are at the end of the other clade of the tree, they should still work fine. So let's go on NCBI, nucleotide, Thamnophis, reg1. Once we search it, we would like to have the complete one, not the partial ones. Now these are predicted, but I'm pretty sure they should work just fine. So I would like to download this, copy the name, file, gene bank or FASTA format, and then create file, and then it should be downloaded. Now we're gonna do this again, and from this database we have to find another one that has the reg1 available. In this case, for this species, we actually have it available. Nucleotide, search, and as you can see, it is predicted, but it is available. Now, let's download this as well, and after that, we're going to take these two onto Geneious Prime. So, let's create another folder and start from scratch. Trial 2. Let's bring these in, keep the sequences separate, and I will rename these. Batch rename, replace with description. Okay, now they're gonna turn into this. Yep, let's remove the predicted part. And after that, let's align them. Class Omega should be fine. And voila. Starting from the beginning position to the ending position, there are some differences, especially in the earlier parts of the reg1 gene. But other than that, I would say it's quite conserved. Conserved in terms of we have quite a bit of parts that are, as you can see, 38 columns long and preserved completely. Or there's another one right here, 40 columns that are preserved completely. Or even within this 79 columns, we only have one nucleotide change, which should be just fine when we're doing the PCRs. And after that, it is pretty simple. We're gonna select here, let's say, from the beginning position to the ending position. Let's go for the most variable part, which is the first 1500 base pairs. Let's click on Tools, Primers, Design New Primers, Included Region, yes, Product Size, this, numbers of pairs to generate 6, and then let's click on OK. And after that, let's save it and take a look at the results. We have one primer, 1, 2, 3, 4, 5, 6 forward primers were designed, and 6 of the reverse primers are designed. Now, one thing is you cannot match this with this one because it's not optimally designed to use them together. It might work, but what this program does is basically creates the sets that can be used together on the same row. So this 1425R can be used with 118 forward or 226F. Or this 1458R can be used with 118F or 226F. And this is how you design nuclear primers on Geneious Prime.